Hi there, you right? So, in this video, we're going to be looking at 9G gradients, okay? So I'm going to fill out these notes here. Hopefully you've received them. If you don't have the hard copy, there is a digital copy here that you can download, PDF file you can download, and you can print yourself as well. But today's lesson, there are two key skills that you want to take away, okay? So by the end of this video, I want to teach you, number one, types of gradients. Okay, so how do you determine what type of gradients there are? Now, there are 4 of them. Okay, and then skill number two is how do you find the gradient? Now, there's 2 ways to do it. One way is through the graph, and one way is calculation. Okay, that's pretty much it. Those are the 2 key skills that I'm going to be looking at to teach you. So let's start off with the first point. What is a gradient? Now, let's look at this y equals mx plus c. What is this? Now, hopefully you realize that after doing exercise 9b and 9f, that you realize the equations that you've been sketching have been something like this. It has been like y equals x plus 1. Or y is equal to 2x minus 3. Or it could be y equals to negative 4x. Something like that. But notice in all of them that the x, power of the x is currently to the power of 1. There's not power of 2, not power of 3. It's not x to the power of 2. It's not x to the power of 3. It's just x. And that is a hint. Every time you see an x, just an x in an equation, the graph will end up being linear, meaning it's going to be a straight line. I'm going to prove it to you on Desmos so you can see. So watch what happens here. I'm going to change the equation. I'm going to go Desmos and watch this. Let's go to Desmos. Watch what happens when I do y equals. Now, as long as you have the letter x in there, it's always going to be a straight line, no matter what you do next. If you do plus 1, you do minus 1, you do minus half, or it's half, it's still a straight line. See, all I need to do, I'm going to change the color just so it looks better. Let's do orange. Okay. I can even put a fraction in front of the x. I can do, instead of 2x or 3x or 4x, I can change it to a quarter. I can change it to a negative. See, as long as I have just an x there, it will always be a straight line. Even if I wrote it like this. Even if I wrote it as x minus 1 all over 3. See, notice how I put brackets, but there's only 1x. And even then, it's still a straight line. You see that? So even if I put a 2 in front of the brackets, and then I say plus 7 or 8, it's still a straight line. So what we're now saying is you can make up any rule you want. Okay, so as long as y is equal to, and if you just put an x there, and then you come up with any other number you want for m and c, okay, in those positions, no matter what numbers you come up with, it will always be a straight line. Notice the language I said numbers. I never said another letter. See, if you used, like if this was y, for example, that wouldn't work. Or if you did another x there, that wouldn't work. It will be a different graph. So for example, if I went back and I did x and I said times x, see how it changes the graph? Or I did, well, a will still work actually, but actually I don't want to confuse you now. Just the point is it has to stay as x. And every other number that you put in front of x and you add or subtract to x, so if I add 1, it will still be a linear. Now remember, when you put a number in front of x, okay, like this one, see how I put a number in front of x, or I put a number in front of x here? That's a negative 4 in front of x. What was happening between the x and the number? Remember, it's not adding, subtracting. It's actually doing multiplication. Okay, so you either m represents the number that's multiplied to x, okay, and then this c value is what you're adding or subtracting. So multiplying or dividing, and this is adding or subtracting. Okay, now there's a special name for each one, so I want you to fill in the box here. M actually will tell you, so the number that you multiply to x will actually tell you the gradient. C tells you the y-intercept. Do you remember what I talked about in exercise 9F to find the y-intercept? Let's test you. So think about this. If I'm going to ask you this question, I say, if you want to find the y-intercept, what do you let equal to 0 again? Which one was it? So y-axis intercept. So this is the y-axis. If I have a point that touches on the y-axis, what must be 0? Have a think. Hopefully you remembered it was x is always 0 because you don't move left or right. The coordinates stay right at the center. It only moves up or down. So that's why x is always 0, but we don't know what y is. Okay? And if you test that in this rule, you'll see y equals to mx plus c. If you wanted to test it, you said x has to be 0, right? You said x is going to be 0. So if this is going to be 0, you end up with y is equal to m times 0 plus c. But m times 0, whatever you times 0 is going to be 0. And 0 plus c gives you y equals c. And what does that mean? That just meant that you found out when x is equal to 0, the y-coordinate will equal to c. So the y-intercept will always be 0 and whatever the number of c is. That's why we call it the y-intercept. Okay? So that's why whatever number you put for c, it's going to be the y-intercept. So what do I mean by that? I want you to see this. Have a look at this. So notice it's x, right? Watch what happens when I do plus 3. See this plus 3, when I'm adding to the linear equation, when I put a plus 3, notice that the y-intercept, where does it cross the y-axis? Look at that. It's at 0, 3. Exactly 0, 3. See, if I change this now to 4, it'll be at 0, 4. See, that's where the y-intercept is. If I change this to minus 4, notice where the y-intercept would be. It should be at 0, negative 4. So every time I type an equation for you, if I said, what would the graph of y equals, okay, I'm just going to say x minus half. So where do you think that's going to be? Okay, where will it touch the y-axis? If I said minus half. Now when I do minus half, hopefully you figured out that it should touch the y-axis at negative half. Watch this. I'm going to zoom in. And can you see there, right there, it touches the y-axis at exactly negative half, negative 0.5 for that green line. Okay, so that's what the y-intercept represents, or C represents. C represents the y-intercept. Y is at the y-intercept. You can prove it by substituting x equals 0 into the equation, and then you'll get y equals C. Okay, so that's a bit of a theory that you don't need to know it. I just thought I'd show you. Okay, remember the main focus for today is finding the gradient and then determining the types of gradients. Okay, so you don't need to know the y-intercept. It's just nice to know. All right, gradient. So let's go back. What is the gradient? The gradient is the number that you're multiplying to x. Okay, so the number in front of x, that's the gradient. So here we go. Let's do a bit of a test. Here we go. So this is y equals, this is x. Now the number I put in front of it is the gradient. So 3 times x, that's a gradient. If I do another one, y equals 4x. 4 is the gradient. Okay, so that's the green line. Let's say I do y equals to half x. Half is the gradient. Now what you see is that the numbers that when I change them, have you noticed what's happened? See the first one in blue, when it's 3, it's this line, the blue line. But when I increase it by 1, so the larger it gets, have you noticed the line gets steeper? Does that make sense? The line gets steeper. So it started off like this. Started off like this, where the line was like this. And then when I increased the number, the line got steeper. That means that the larger the number, okay, the larger the number I change, if I change that from 3 to 4 to say 99, it should be really steep. Okay, so watch this. When I change that 4, okay, so 4 is currently steep, which 5, 6, 7, 8, and watch what happens when I go to 99. You see how steep it is? See that green line? It's very steep, isn't it? It's a very steep line compared to 3. So that's what the gradient is. The gradient is how steep a line is. It determines how steep. And the larger the number is, the steeper it is. And the smaller the number, the flatter it will look. So what do I mean by that? Notice before I had half. See, half is quite small. See how it's flatter than the blue line? The purple line's flatter. Watch what happens when I make it even smaller. What's more than 0.5? Let's do 0.2. Oh, that's a bit too much. Can you see 0.2 is flatter? And watch what happens when I change it to 0.2, 0.1, 0.01. It's getting even flatter. Can you see that? It's getting really flat. So the smaller the gradient, so the number that is in front of x, the smaller the number, the flatter it becomes. Okay? Let's now pause there. Pause there for now. Let's just see if you can determine the y-intercept and the gradients of each equation. Okay, so let's go to your textbook. I'm just going to choose a few equations to test your understanding. Oh, they don't have any equations there. All right, I'm going to pick, I think it's the next one, 9H. All right, I'm going to pick a few equations just so that you can see. All right, let's look at 2a. Y equals 4x plus 2. What is the gradient and what is the y-intercept? Have a think. Look at my notes. Pause the video. Okay. Hopefully you said the gradient, m should be 4, and then the y-intercept is this one. This is the y-intercept. So then that should be c is equal to 2. Okay, so it should mean that the graph will cross through 0, 2, because that's the y-intercept. And we've got a gradient for which I haven't told you what it looks like, but we know that it's steep. Okay, I'm going to show you what it looks like, the type, so that you can sort of figure it out. But let's go. What about this one? What's my gradient? What's my y-intercept? Hopefully you picked up. Gradient is 3. What's the gradient for this one? This is -4. What's the gradient for this one? Even though you don't see the number, it's technically -1. Okay, let's see. Gradient for this equation. Hopefully you picked up. It's the number in front of x, which is half. So m equals half. What's the gradient for this one? Gradient is 2/3. Very good. If you then went to look for the y-intercept, this is the y-intercept. It's the number that you're adding on or subtracting 2x. So here I'm adding on 7. So 0.7 is the y-intercept. This one is 0.4 is the y-intercept. This one is 0.6 is the y-intercept. What about this one? Hopefully you pick up that it is 0, +1. If you got that, well done. Okay, so that's determining gradient and y-intercept from an equation. All right, now let's go back to our notes again. So here's our notes. All right. Now, the gradient, yes, we know if it's going to be steep or flat, but we don't know what the number represents. So here, I'm going to get you to memorize a few things. There are 4 types of gradients. So this is one of the first skills I said. I want you to learn the 4 types of gradients. What are the 4 types? We've got positive, negative, 0, and undefined. I'll explain that much later. Okay? As long as you see from left to right, if the line looks like it's going up, see how it's going up? So the more you, from left to right, if it looks like it's going up, that's a positive graph. Okay, that's a positive graph. If from left to right, it looks like it's going down, okay, so it's going down as I'm moving towards the right, so it's going down. This is a negative gradient. Then if you have a flat, an absolute flat line, this is a gradient of 0, so super flat, horizontal. Whereas if you have a very steep vertical line, okay, whoops, that's a diagonal there. Let's draw a nice vertical line. If you have a nice steep vertical line like this one, so infinitely steep, then this is, so it's very steep, then that's called the undefined gradient. Okay, so you just need to be able to look at the shape and then determine what type of gradient you have. So let's have a look at this one. What is the what type of gradient is this one? Have a look from left to right. Is it going up or is it going down, or is it flat or is it vertical? Hopefully you can see it's going up from left to right. So this is a positive type of gradient. What about this one? What type of gradient is this one now? And hopefully, again, you notice that from left to right, it's also still going up. It's a bit flatter, but still, it's a positive gradient. So far, so good. Let's go to your textbook. Let's see if you can identify the types. Actually, no, not that one. Yeah, I'll do this one. All right, let's see. Just tell me the types. We don't have to calculate the gradient just yet. Just tell me the types. So hopefully, A, what type is it? Positive. B, what type is this? Positive again, because it's moving from left to right. It's going up, up, up. So positive. This one's still positive. This one's positive as well. They're all positive. This one's positive, positive, positive. Then if you look at the next one, negative, 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 negative. Okay, so you can see the questions they've specifically chosen that the first one was going to be question 3 was all positive and then question 4 was all negatives. Okay, so that's the first skill, is to work out the type of gradients you have. All right, let's going back to our notes. So how do you calculate what the gradient is? So here, for example 1, it says find the gradient. To find the gradient, see, the steepness of a line is determined by 2 things. It's from this point to this point. So let's say A to B, you had to move horizontally by a certain amount, and then you have to move vertically by a certain amount. So there's always this ratio to make this diagonal. So we call this the x values, okay? So how far you go across, and then how far you go up or down is the y values. So the definition of a gradient, m is equal to how far you go up or down, and how far do you go left or right. So we normally call it rise over run. So that helps you remember rise is up and down, and run is how far you go left and right. So you always got to pick 2 points, because remember, to draw a straight line, you always need 2 points, so A and B. So let's look at this graph here. Pick 2 points. I clearly can see there's a point at 1, 3, but let's pick another one that you can see. Can you see another point? See, I see another point that I definitely know is right here at the origin, is when x is 0, y is 0. So with that graph now, how far do I have to move from A to B? See, horizontally, I have to go across 1. Then I have to go up. How much do I have to go up by? By 3. Okay, so 1 across and then 3 up. So my gradient in this scenario would be I had to go 1 across, 3 positive up, and so the ratio is 3 divided by 1 is 3. So when we say gradient of 3, we actually mean rise by 3 and 1 across. That's what these positive signs mean. Okay, notice that 3 is a positive number. It's a positive 3, it's not a negative 3, positive 3. And so that's why the graph is also positive. Yes? Let's pick another one. I'm going to pick one from the equation so you can see how I do it. So let's pick number 4. Pick 2 points that you can see. So let's say I'll do F. Okay, so this point is negative 2, 5. So that's A. My second point, let's say 0, 2 is B. Now, if I want to know the gradient, remember gradient is how much you rise by how much you run. So how far do you have to go across, and how far do you have to go up or down? So from left to right, from A, I needed to go across 1, 2 units across. And then I have to go from 5, because starting at 5 up here, I needed to go down to 2. So how many units is that? 5 to 2, I have to go down by 3. So hopefully you can see the rise and run. Well, I had to go down 3, so down 3, then across by 2, to the right by 2, so positive 2. Negative 3 over 2 is the same thing as saying negative 3 divided by 2, and that's what my gradient is. It's negative, which makes sense because this is a negative type of gradient. See that? So that's one of the first skills I'm trying to teach you in the notes. So remember I said you need to identify the 4 types. So what were the 4 types again? You had positive, negative, 0, and undefined gradient. Okay, so that's the first skill. Second one was to find the gradient of a graph. And this was using rise over run. Okay, rise over run. That's what I just showed you just now. So if I were to find the gradient in this scenario, this gradient, I want to know the number. Pick 2 points. I can see this is a point, negative 2, 6, so that's called that A. I've got another point, 0, 3, let's call that B. And then let's work it out. So rise over run. If I'm moving from left to right, I clearly have to go down 3. Okay, went from 6, 5, 4 down to 3. So down 3. But then I have to go to the right by 2. So that means this gives me now rise is negative 3, run is positive 2, and the gradient is negative 3 on 2. Okay, hopefully that's giving you a bit of a direction on how to answer these questions for the types. Okay. The last bit of today is sometimes you don't actually always have to have a graph to work out the gradients. Okay, this is clearly a 0 gradient because it's horizontal. Okay, and we can tell because if you pick 2 points, we can prove it. Pick 2 points. Say this point is 1, 2, and you pick another point. Let's say that's 3, 2. If I asked you m, which is rise over run, can you see, did you have to move up or down to go from point A to point B? No. So you moved 0 rise, but how far did you have to go across? From 1 to 3. From 1 to 3, that's 2 units. So that's why it's run by 2, but 0 divided by 2 is 0. This is why we call it 0 gradient. Okay? So what happens, and this is the last skill for today's lesson, so you now know how to read the 4 types. So you got positive, negative, 0, undefined. Then the last part of it is, well, how do I work out the gradient without having a graph? Okay, so what if you didn't have the graph? So say, for example, you had just that, 0, 2, and 1, 6. Now, if you had this scenario where they just gave you the coordinates, there is a formula that I want you to copy down to work out the gradient. Okay, the formula is y2 minus y1 over x2 minus x1. Now, you might be wondering, what is this y2, y1, x2, x1? It represents the x coordinate of the first point, so we call it x1, and this is the y coordinate of the first point. Whereas the second one, we call it x2 because it's the second x coordinate, or the x coordinate of the second point. And then this is the y2 because it's the y coordinate of the second point. Technically, it doesn't matter which one you label. You can flip it around. You could have called this x1, and this is x2, and this is y2, and then y1. The calculation will still be the same. Okay, it doesn't actually matter. You just need to make sure this stays as a group, so x1, y1, and this stays as a group, x2, y2. Okay? Now, if we were to calculate this then, so what is my y2? Y2 is clearly 6. Take away, what's my y1? Y1 is the 2. So 6 take away 2, divided by, now the next one is x2. This is my x2, so it's 1. Take away x1. What's my x1? x1 is 0. So if you simplify this problem now, that becomes 6 take away 2 is 4. Divided by 1 take away 0 is 1. So the gradient is 4. That's what the gradient equals to. So gradient of 4. How does that look on a graph? So this is what I mean. You don't actually have to draw the graph, but if I draw the graph, it makes more sense to you how you would get m equals 4. Okay, so 0, 2. 0, 2 is somewhere over here. X is 0, so it doesn't move left or right. Goes up by 2. So you got 0, 2. The next one is 1, 6. So I go from 1 and I go all the way to 6. So here we go. That's 6. That's 1, 6. So if I connect the little dots, hopefully you can see. Wait, that's 4. 1, 2, 3, 4. There. All right. You can see how we would have calculated to find the gradient. Okay, so to find the gradient, remember, we are looking for, whoops, let me just try to fix that. We are looking for 2 points, so from A to B. Now, if you think about it, can you see how far did I have to go across by? I have to go across 1 unit. And then how far do I have to go up by? So from 2 to 6. That's 4 units there. Can you see that? From 2 to 6 is 4 units. And then this one was from 0 to 1. That's why when you write out the gradient, doesn't it make sense? Rise over run. Rise is 4, and you ran across by 1, which is why it's 4. Okay, so that's the graphical way. But I'm trying to teach you the second skill where you don't need the graph, you can use the formula. The formula is really, if you notice what the formula is really doing, aren't you really just getting the y value? So 6 take away 2, isn't that just vertical distance? Right? And then the other one is x2 take away x1. Isn't that just taking the x coordinates and finding the difference? So you're just working out horizontally the horizontal distance. Okay? So if what I just described doesn't make sense, again, just follow the rule. So gradient rule is y2 minus y1 over x2 minus x1. And again, doesn't matter about the label. This time I'm going to swap it around. So I'm going to call this now x2, y2. Then this is x1, y1. Watch what happens when I sub it in. So here we go. y2 is currently 6. Take away y1, which is currently 0. And x2, which is currently -5. Take away y1, which is 1. So what does my gradient tend towards? 6 take away 0 is 6. -5 take away 1 is -6. And 6 divided by -6 is -1. So my gradient is -1. And again, you can plot the coordinates and see if that's true. So if -5, 6, -5 is over here, 6 is up here. I'm just going to delete that. 6 is up here. So -5, 6. That's my point A. And then the other one's 1, 0. So 1, 0 is all the way here. That's 1, 0. So I'm just going to rub this one off so we don't get confused. There you go. That's 1, 0. So if we then connect the dots, now you can look out vertically from point A to point B. You see how vertical this has to be? That is going from 6, okay, so 6 all the way down to 0. So that's 6 units there. Oh, I drew it wrong, didn't I? So 6 was, oh no, that was 6. 6 was here. Whoops, I was right. I'll do it again. No, 6 was here. So we know that the rise is 6, okay? And I had to go down by 6, actually. So I went from here, went down 6. Then I needed to go across by how much? From -5 to 1. See, up to 1. So what's the distance from -5 to 1? 6. Okay, and then you can see by doing that, rise on run. Same thing again, rise over run. Rise is -6 because I'm going down 6. And then I'm going across by 6. So -6 over 6 is -1. And that's my gradient. Okay, so if you put it all together, that's all you need to know. So you just need to know types of gradients, which there are 4 types. You just need to know how to find a gradient and what does the gradient represent. Now, when to find a gradient, there are 2 ways, one through the graph and one through calculations. All right, next week, I'm going to go through more of this as well, just to keep practicing that ability to determine the gradient. You can watch my previous videos, okay, to help you as well. So last year's video and then this video from 2022 should be able to help you understand how to find the gradient. But the main 2 things, like I said, I want you to be able to tell me types of gradients and then how to find it either through a graph or calculation. Calculation, you use y2 minus y1 over x2 minus x1. All right, I'm going to stop the video there.